Assalamu alaikum dear students. Today we have to continue with unit 5 sets and functions, and the topic for today is properties of union and intersection. So let's begin with the topic. Properties of union and intersection. The first property here is associative properties with respect of union and intersection. So let's see that what associative properties of union states. It states that if we take the union of B with C, then we take their union with A, so we'll get the same answer as we take the union of A and B, then we take their union with C. So in associative properties, three sets will be involved: set A, set B, and set C. Similarly, the associative property of intersection states that if we take the intersection of B and C, then we take their intersection with A. So we'll get the same answer as we take the intersection of A and B, then with C. Next, we have commutative properties of union and intersection. So commutative properties of union states that A union B is equal to B union A. Similarly, a commutative property of intersection states that A intersection B is equal to B intersection A. In addition, we have the distributive properties here. We have two types of distributive properties. The first one is distributive property of intersection over union. If intersection sign is first and then union, so it is known as distributive property of intersection over union. The next one is distributive property of union, because union is first over intersection. So this law holds true that if we take the union of B and C, then we take their intersection with A, so it will be equal to A intersection B union A intersection C. Because we can see the bracket in the left hand side, so bracket sign shows that the intersection of A and B can also be taken as A intersection B, then union sign from here, then A intersection C. Similarly, A union B, then intersection, then A union C, as here we can see bracket. Okay, next we have De Morgan's law. This is also one of the properties of union and intersection. Let's see that what De Morgan's law states. De Morgan was basically a mathematician, a British mathematician. He introduced this law, so on his name this law is kept as a De Morgan's law. So De Morgan's law states that if we have two sets A and B, so if we take the intersection of A and B, then we take their complement. Whenever you see this dash sign or C, so it means this set should be subtracted from the U, the universal set. So this law states that if A intersection B is taken, then their complement is taken. So it will be equal to A complement union B complement. We have two parts of De Morgan's law. The first one, if we take with intersection, so in the right hand side that we have to go with union. If it is whole complement, so in the right hand side that there will have the separate complement of A and B. So it's very easy to recognize or memorize De Morgan's law, that if it is intersection, so here will be union. If it is whole, so here will be separate complements. If it is union, so here will be intersection. If it is whole, so here will be separate complements on A and B. So in the exercise we are going to verify these all properties of union and intersection. So let's begin with the exercise 5.2. Here we have question number 1. If set X is equal to 1 3 5 7, then we can see 3 doors here and 19. It means that this is continued till 19, and 19 is the last limit. So therefore 3 doors are put here, which is showing the continuity. So here we can see that all these numbers are odd numbers, so this is the series of odd numbers till 19. If we see set Y, so here we have 0 2 4 6 8, then 20. Here we have the set of even numbers. And if we see set Z or Z, so we can see here the prime numbers 2 3 5 7 11 13 17 19 23. These are all the prime numbers, and prime numbers are those numbers which have two factors. So let's find the second part, X union Y union Z. Here we can see round bracket. So round bracket shows that first of all X union Y should be taken, then their union should be taken with Z. So here we can write X set, then union sign, then Y set. So we know that set X contains of set X contains of odd elements and set Y contains of contain even elements. So when we take their combination, their union, so of course we will have all the numbers because odd and even. So all the numbers will be here from 0 till 20. 0 from here, 1 from here, then 2 from this set, 3 from this set, and so on. So we will have the set from 0 till 20. Now we are going to take this set, the union means this their union with Z. So X union Y, this set is written, then union sign, then now this is set Z. Set Z, this contains of prime numbers. So if we combine all the numbers with prime numbers, of course this all numbers till 19 will be also in this set. So from 0 till 20 from this set, and 23 is in this set, so we are not going to ignore as we are taking the union. So we'll write 23 also here. This is the answer. Question number 1, the fourth part is here. We are going to find the intersection of X and Y, then we have to take their intersection with Z. So first of all, the round bracket, X intersection Y. We know that this set contains of odd elements and this set has the even elements, so there is no common between odd and even, so therefore no common elements, so we can write empty set here. Now we have to take the intersection of this empty set with Z. So of course this is empty set, means having no elements, and here we have the prime numbers, so again there is no any common element, so we have the answer as empty set. Now we have the fourth part. Fourth part states that first of all we are going to take the union of X and Y and union of X and Z, then we are going to take their intersection. So first of all, let's solve the bracket X union Y. So this is X set and this is Y set, and their union will be from 0 till 20, means the combination of even and odd numbers. Next is X union Z. X union Z has X set consists of even odd elements, and set Z consists of prime numbers. So of course from here we can take 1, from here we can take 2, then 3, then 5, 7. Now till 19 we will be having all the numbers, means 5, 7, then 9, then 11 means the odd numbers, then 23 till here we have 19, then 23 should come from this set, and we are not going to ignore this. Now we are going to take X union Y, then common, then X union Z from here. Okay, between them what will be the common factors? Now 0 is not common, 1 is common, 2 is common, 3 is common, 5 is common, 7 is common, and till 19 all the elements will be common, because we have here all the numbers, and here we have just the we can see the odd numbers 2, 3, 5, 7, 11, 9, 11. So here after 2, so all the odd numbers till 19 will be common. 20 and 23 are not common, so we are not going to write this. We have here question number 2. If set A has the elements 1, 2, 3, 4, 5, 6, and set B has the elements 2, 4, 6, and 8, and set C has the elements 1, 4, 8, then we have to prove the given identities. Here we are going to prove the properties of union and intersection. So let's see that this is the which property? Distributive property of union over intersection. First here is union, then intersection, so this is known as distributive property of union over intersection. So it will be A union B equal to, then intersection sign, then A union C. So we are going to prove this. First of all, we have to go with the left hand side and then right hand side. So left hand side is here. Under A we are going to write set A, then union sign, then a bracket, then set B, then intersection, then set C. So first of all you can find B intersection C because it exists in round brackets. So let's see what will be the common between B and C. 4 and 8 are the common elements. Now B and C is found. Now we have to take the union of these with A. So the union means the combination. So 1, 2, 3, 4, 5, 6 in 8 all the elements will be here, and 4 is in both the sets, so it should not be repeated, it should be written one time. Right hand side is A union B, so under A means first bracket, then set A, then union sign, then set B, then bracket closed, then intersection sign here, then again bracket, then set A, then union, then set C here. So let's find the union of A union B. So 1 2 3 4 5 6 and 8 we will get, then intersection sign from here, then union of A and C. So of course 1 2 3 4 5 6 and 8, both the same answers. So when we'll take their intersection, means the common, so all the numbers are common, 1 2 3 4 5 6 and 8, so we'll get the same answer. Hence left hand side is equal to right hand side, and it is verified here. Next is question number 3. If U is equal to 1 2 3, U is the universal set here, 1 2 3 4 5 6 7 8 9 10, and okay, set A is equal to 1 3 5, it is not 57, it is 5 7 then 9, and set B is 2 3 5 and 7. Then we have to verify the De Morgan's law. This A and B are the subsets of universal set because their elements are present in universal set. So universal set is here the big set, and A and B are the subsets of this universal set. So here we have to verify the De Morgan's law, as it was already discussed that De Morgan's law has two parts, and both the parts should be verified. First part, if we take if it is intersection, so here it will be union. If it is union, so it will be intersection. So we are going to prove it. Let's write here the first part. A intersection B whole complement, then A complement union B complement. So here first of all left hand side, then right hand side, then we will go with the second part, left hand side and right hand side. So let's solve the left hand side here, and we know that complement means that it should be subtracted from U. Since it is whole complement, so A intersection should be subtracted from U. So first of all set U should be written, then minus sign, then bracket, then set A, then intersection sign, then set B. So since we have here first of all the round bracket, so first of all the round bracket should be solved, then it should be subtracted from universal set. So let's see what will be common between these A and B. 3, 5 and 7 are the common elements. Now we have to subtract it from U, and in subtraction you know that what can be cancelled. We can take the pen from here. 3 3 5 5 and 7 7. So what is left in U? The elements 1 2 4 6 8 and 9 and 10 are left. So this is the A intersection B complement. Let's go with the next part here. Right hand side, A complement means U minus A, then this union sign, then B complement means U minus B. So first set U is written, this is set U, then minus sign, then this is set A, then bracket is closed, then now union sign, then set U, then minus sign, then set B. Okay, let's find the U minus A first. Now you can see 1 is cancelled, 3 5 7 9, 1 3 5 7 9 are subtracted. So what is left in set U? 2 4 6 8 and 10 are left. Similarly, if we can see here that from U if we subtract B, so 2 will be subtracted, 3 5 7 is 2 3 5 7. So what is left in set U? 1 4 6 8 9 and 10 are left. So we can write it here. This. Now we are going to take U minus A is also found and U minus B is also found. Now we are going to take their union. So their union will be 1 from here, 2 from here, 4 6 8 9 and 10. So we can see here that left hand side is equal to right hand side. So here the first part of De Morgan law is proved. Now let's go with the second part of De Morgan's law. It is that if you we take the union and whole complement, so it will be equal to A complement intersection B complement. So first of all, let's go with the left hand side. Complement means U should be A union B should be subtracted from the universal set. So first set U is written, then minus sign, then set A, then this is, let me rectify this mistake, this is union. Okay, then union, then set B. First of all, let's take solve the round bracket A union B. So their union will be equal to 1 2 3 5 7 9, the combination. Now it should be subtracted from universal set. So 1 is subtracted, 2 3 5 7 and 9 are subtracted. What is left? Of course 4 is left, 6 8 9 and 10 are left here. Okay, let's go with the right hand side now. Is A complement means U minus A and B complement means U minus B, and here is the intersection sign. So U set, then minus A, then intersection sign, then U set, then minus B. We are going to follow this. Okay, from U we are going to subtract a should be subtracted from u. So let's see that if you it said u is from 1 till 10. So if you subtract the even odd numbers, so what are left? Of course, even numbers, 2, 4, 6 and 10 are left here. Similarly, if we subtract the prime numbers from here, so 1 is left, then 4, 6, 8, 9 and 10. 1 and 9 are not in prime numbers, so this will left here. Now when we'll take the common between them, so 2 is common, 4 is common, 6 is common, 8, 9 is not common here. So we are not supposed to write 9 here. Of course, here also 9 will not come. Let me rectify the mistake. 9 minus 9 will get subtracted, so this 9 should not come here. Similarly, this 9 should not come here. So we have the same answers of left hand side and right hand side. So here we are done with this. Next is question number 4. If u is equal to from 1 till 20, we have, and set x is equal to 1, 3, 7, 9, 15, 18 and 20, and set y consists of the odd numbers from 1 till 17, as 1, 3 and 5 are odd numbers, so it is the series of odd number. We are going to show that x minus y is equal to x intersection y complement. So first of all, let's solve the left hand side, x minus y. Here is set x and here is set y. Now we can subtract. You can see 1 can be subtracted, 3 with 3, 7 with 7, 9 with 9 and 15 with 15. So what is left in set x? 18 and 20. Remember one thing, that you are subtracting y from x, so whatever element is left in x in the first set, because you are subtracting the elements of y from x, so whatever is left in x, you are going to write that in those in answers. You are not going to write the elements of set y. Okay, now see the right hand side. We have x intersection y complement. So we cannot find x and intersection y complement until and unless y complement is first found. So first of all, let's find the y complement. Y complement is equal to u minus y. So this is the set u here and this is the set y. We can write the elements from here. All the elements is written here, all the odd numbers. So let's see that if we subtract all the odd numbers till 17, so we'll get only even numbers till 18. Then since here is no 19, so 19 will come from here, then 20 from here. This is y complement. Now we are going to take the intersection of x with y complement. This is x set, this is intersection, and this is y complement. You can see that 18 and 20 are the common elements. So here left hand side is equal to right hand side, and here we are done with the exercise 5.2. I hope the exercise is clear to you. This is your assignment for today. What you are going to do, you have to do exercise 5.2, all the questions on your neat notebook. In addition, you are going to prepare the presentation of exercise 5.3, because 5.3 is similar with 5.2. all the concepts are same, the same properties are discussed and are again given in exercise 5.3. so I want you to go with the presentation. You can prepare the presentation of at least one question. Fine, I will myself assign the presentation in the online class to the students. Then you have to share your presentation on Saturday, inshallah. Have a nice day, stay blessed. This is all for today.